Good morning, guys. We're going to go over Lesson 5 using matrices. Really important section, so hopefully you're able to watch this video. So first things first is a matrix is a way to organize, a way to organize data. And we name a matrix by writing its rows by columns. Example, if I have the following matrix, so I'm going to give you guys a matrix, negative 1, 4, 3, 0, negative 5, 7. Now, let's go over a couple things. These here, I probably shouldn't use that. These here are my rows. These are columns. So if I was to name this, I'm going to list my rows first. So I have 3 rows by 2 columns. So this would be named a 3 by 2 because it's rows and then columns. So if you want to pause it, what would I name this following matrix? If I have 3, negative 6, 2, 11. So what would I call, you can pause my video, is this a 2 by 2, a 1 by 4, a 4 by 1, a 3 by 5. Okay, you can pause it. If you've already done it, I know I have 4 rows and only 1 column, right? I have 1, 2, 3, 4 rows. That right there is my only column. So I would say this is a 4 by 1. Okay, so that's how we name them. Now our matrices, like I said, can be used to organize data. And so I'm going to go over adding matrices by doing lesson practice part E. I think it would be, well, we can do one together and then we'll do our lesson practice in a second. So example 2, we're going to add the following matrices. Now to add matrices, they have to have the same name. They have to have the same dimensions. So I'm going to put dimensions or name. Okay, so we're going to add the following. If I have, I'm going to keep the one above, negative 1, 4, 3, and 0, negative 5, 7, plus 6, negative 8, 5, negative 3, negative 2, 12. If I add these, I will add the numbers in the same spot. For example, negative 1, I should use my yellow highlighter. Negative 1 matches the position of 6. And so I'm going to add negative 1 plus 6. That means that 4 would match negative 8, right? They're both second down on the left. So 4 plus negative 8. The bottom would be 3 plus 5. Here, now I'm 0, negative 3. Here would be negative 5 plus negative 2. And last 7 plus 12. So I'm going to add each of those to get my final answer. So again, you're just matching the position they're in. So negative 1 and 6 go together. 0 and negative 3 go together. These go together. These go together. These go together. These go together. So if I add these up, I get 5, negative 3, negative 4, negative 7, 8, and 19. And this would be my answer. Okay? Next thing we're going to go over is what is an additive inverse. An additive inverse is the same numbers but changed signs. Okay? So, if I said, what is the additive inverse of of 3, -6 to an 11? Okay? The additive inverse would be -3, +6, -2, -11. You would simply just change the sign of all four, and that would be your answer. Okay? Now, next, I'm going to go over subtracting. I'm going to turn the page. It's very similar to adding. I'm going to go over subtracting matrices. And I'm going to use the same one, same matrices from the previous page. And except for I can't turn back that page without losing you here. So I'm going to just write two matrices. So what if I have -1, 4, 3, 0, -5, 7, minus -6, 2, -10, 14, -2, and 0. So how to subtract? It's very similar to adding. You pick it in the same position. The book goes over, instead of subtracting this, I can add the additive inverse. You can do that. Or you can simply set this up. So that means that I would match positions. So I am in the first, I have -1 minus a -6, right? In the second position, I have 4 minus 2. And then the next one is 3 minus a -10. In this column, I have 0 minus 14. -5 minus -2, 7 minus 0. And then I would simplify each spot. So know that I paired my matching positions. The only difference is we're subtracting. And now I'm going to simplify. So this is really, right, these becomes -1 plus 6. So this here is just 5. This would be 2. This here becomes 3 plus 10, right, the two negatives, so this is 13. This is -14. This, right, becomes -5 plus 2, so I get -3, and this is 7. So this would be my final answer. So let's go to the next part of this lesson, where I'm either solving or finding the missing pieces. So, next one. Well, we'll just do that in the lesson practice. All right, and so we're just going to go ahead and start on the lesson practice because I think the rest is review. Sorry, I changed the order from last year, and that's why I was like stumbling. Lesson practice is on page 33, and let's start with part A. Again, you can pause this video anytime. So part A asks us it gives us the data on two different stores, the West Side store and the East Side store. And it asks us to organize the information and then to add them. So it says to find matrix W plus matrix E. And so matrix W, I'm just going to organize the data. I'm going to keep everything in the same position. So 13, 1, 4, 6, 8, 2. So that should match the table on page 33. And it's asking me to add, and then matrix E, I'm going to just organize the table they provided. So in the first column, they have 0, 4. Undersized medium, they have 11 and 2. And under large, they have 3 and 5. So if I add these together, right, let's start with 13 and 0. So starting with the top left, 13 plus 0 is 13. Next position, 4 plus 11 is 15. 8 plus 3 is 11. Bottom, 1 plus 4 is 5. 6 plus 2 is 8. 2 plus 5 is 7. Really simple, right, guys? We just add the numbers in the matching position. So that is A. In part B, it said define the additive inverse of the following matrix. So 1, negative 1, and 5. Remember, the only thing I'm going to do, I'm going to keep the numbers but change the sign. So instead of positive 1, negative 1. Instead of negative 1, positive 1. Instead of 5, negative 5. That's it. Okay, moving on. Oh, I guess the lesson practice goes from page 32 to 33. So moving on to C. So part, where did I write part C? Part C asks us to subtract the following. So it says to subtract the following two matrix. So the first matrix, they gave me a negative 1, 6, and 5, and 0, negative 8, and 3. And they want me to subtract the following. I'm working columns going down, 2, 2, 5, and negative 4, negative 1, and negative 3. Again, you can pause the video, do the work, and then see if it matches mine. So, I'm going to just line them up in matching position. So this first is negative 1, but they're asking me to subtract 2. Here, I would have 0 minus a negative 4. Here, 6 minus 2. Here, negative 8, I'm subtracting a negative 1. Bottom, 5 minus 5. Here, I have 3 minus a negative 3. So I'm going to simplify that. That gives me negative 1 minus 2 is a negative 3. 6 minus 2 is 4. 5 minus 5 is 0. These both become positive, right? And this is just 0 plus 4. This is negative 8 plus 1. And this is 3 plus 3, which is 6. So this just becomes 0 plus 4. This becomes negative 8 plus 1. This becomes 3 plus 3. And this matrix here is my answer. All right, part D wants me to solve. And I'm just going to turn the page so it's a little easier for you to see. So part D wants me to solve for y. Now I didn't do an example because it's kind of common sense and I think you guys can figure out. So it's y minus the following matrix. 2, negative 4, I'm doing the columns going down. Negative 4, 8. Equals 6, negative 10, 5, and 2. That's a really messy 5. So to solve for y, I would solve it like any other algebra expression. If I want to solve for y, who do I have to get by itself? Y. And so to get y by itself, I'm simply going to add this matrix to both sides. Add to both sides. So I've got 2, negative 4, negative 4, 8, 2, negative 4, negative 4, 8. These will zero out. This becomes 0. And so I'm left with y equals, and I'm going to add these two together. So 6 plus 2, right? I'm doing 6 plus 2, negative 10 plus negative 4, 5 plus negative 4, 2 plus 8. So y equals 8, negative 14, 1, and 10. Easy peasy. Okay? I added this to the left, and I added this to the right in order to get y by itself. All right, last one, because we're going to skip f, is e. Now there's a lot of these. Pretty confident you can do these. Solve for x, y, and z. And that's why I'm only going to do one of these because you guys are pretty smart. 10, I'm going to write the problem down. 10, 20, x negative 5, 1, x minus y equals 10, x plus z, 25, and z, and 1, and 18. Now, I know that the spots have to match. So notice, the top left and the top left are both 10. So if these really do equal, then I know that x must equal 25 because they're both in the top middle. These are both 1. Then if I look at these, x plus z, I don't know what, I can do that one right now, but look at this middle, bottom middle. These must equal each other. Z must equal negative 5 because they're in the bottom middle. So I can do this one, but I know 20 is going to equal that. But what about this one here? I know that x minus y must equal 18 because they're in the same position. And I've already solved for x. X is 25. So 25 minus y equals 18. So I can just solve it by looking at it. 25 minus what is 18? Okay, so I know that 25 minus 7 equals 18. So y must equal 7. So these are pretty simple. You just match their position and you plug in the difference. That is the end of that lesson. I'll write it down on here. We're gonna actually skip part F. Okay? What problems to skip for homework are in Canvas. Goodbye.